C is equal to how much? C is equal to, tell me, what is the formula? Am I not audible? Fahad, Aisha. In terms of lambda and nu, C is equal to what? Flip your pages, flip some pages and tell me. C is
3
equal to?
into 10 raised to 8.
No. In terms of lambda and nu, relationship between lambda, nu and C. What is the relationship? C is equal to?
Lambda into nu.
Very good. Lambda into nu. Okay. So this is the most important relationship that we have studied in the last lecture. Now, with this only, you will write a question. Also, one more thing, what is this? This is wave number, which is equal to 1 upon lambda. You guys remember this? Yes or no? Please tell me.
Yes.
Okay, write the question. Calculate the wave number and frequency of yellow radiation having wavelength 5800 angstroms. Calculate this.
So we have
No.
done this, I think.
No. Still, there is something different here. No? Something different is here. I'm more interested. I know the calculation will be fine. I'm just more interested in the units. Okay. I just want you to see these units and get comfortable with these units. So first thing you will do is you will convert this into what? Meters. Okay. And then you will do the question. फहद, दिल्ली में बहुत गर्मी पड़ रही है क्या?
तो बारिश हुई थी आज.
अच्छा, आज बारिश हुई थी. Okay, that's cool. Also, any news about your half-yearly exams, Aisha, Iram, Fahad?
It's in the
September.
month of August.
आयशा, आप लोगों का कब है?
August.
1st of August. And for Fahad?
नहीं, 1st of August नहीं मतलब कि September की last में भी शुरू हो सकता है.
अच्छा, you no idea.
लेकिन उससे पहले
नहीं, आपकी आवाज सही से नहीं आ रही है. Can you please readjust your mic or something?
अभी हमारी ना समर वेकेशन है, उसके बाद फिर यूनिट टेस्ट होंगे, यानी एक चैप्टर के या 2 चैप्टर के. उसके बाद फिर सितंबर या अगस्त में वो होगा हाफ ईयर.
So आपकी छुट्टियां कब तक है? आई थिंक अगस्त तो आपका छुट्टी रहता है, राइट?
नो, 15th अगस्त को स्कूल स्टार्ट.
15th August. Okay, 15th August. Okay, fine. And Fahad, you are saying around September you will have your half yearly?
Yes.
Okay. When you are done, send your answers on WhatsApp. Let me just take a photo and send it to me. Please remember the rules that I have told you for simplification for rough. Keep in mind those rules and then do this.
Sir, I won't be able to send on WhatsApp, so can I just tell you the answer?
Okay, but once Aisha and Iram they give, then only. Okay.
Okay.
So Fahad, in the first chapter, are you having any problems? Stoichiometry वाले problems, questions में, numericals में?
सर एनसीईआरटी के जो क्वेश्चंस थे उसमें एक दो क्वेश्चंस थोड़े ट्रिकी थे, लेकिन वो हो गए एंड में। और
Okay, right.
इस बुक के जो क्वेश्चंस हैं वो थोड़े अजीब से हैं, वो नहीं।
प्रदीप में आपके?
यस।
Okay, then do something. Then you just keep sending me those photos. Okay, so when we will have our class, then मेरे पास list होगा सवाल, फिर जल्दी हम लोग को time नहीं लगेगा. Okay.
ठीक है, ठीक है।
Yes, Iram and Aisha. What happened? नहीं हो रहा है क्या? Aisha, Iram.
Sir, we are doing.
Okay. Do it fast. 6 मिनट हो गए हैं और ये एक नंबर से ज्यादा का नहीं आएगा, right? So speed बढ़ाइए. It will not be more than 1 marks or 1.5 marks.
So you've received mine?
Received yours. देखिए ये एक्स्ट्रा रम ठीक है। वेव नंबर यू हैव रिटन करेक्टली। ओके, वेव नंबर आपने सही से लिखा हुआ है। फ्रीक्वेंसी में ऐसे लिखने की क्या जरूरत है? दिस इज नॉट फ्रीक्वेंसी ना, फ्रीक्वेंसी बस इतना होता है न्यू। सी दिखा आपको?
नहीं सर।
नहीं दिखा? फ्रीक्वेंसी लिखा आपने इरम? दिख क्या अब? डिड यू सी दिस नाउ? हाँ या ना तो बोलिए, व्हाट हैपेंड?
Yes, yes.
You see now what is the problem? Okay, let me check the answers now. ठीक है। आयशा, what about you?
सर डिवीजन करें।
अच्छा, what will be the unit, Fahad?
सर यूनिट टाइप नहीं कर पा रहा था, लिखा नहीं।
I don't think so. Look, I mean, can you please recheck whatever you have written in the chat and in your copy? They're the same? Yes or no? They're same?
Yes, sir, same.
नहीं, please see them.
नहीं सर, वो 16 है।
भैया बोल रहे थे same है। Okay, so you are saying what is 16? That's fine. वेव नंबर भी देखिए फिर।
ये सर मैंने 6 लिख रखे हैं गलती से।
नहीं, वेव नंबर।
सर 1 मिनट, वो भी 6 लिख रखा है तो 16 करना पड़ेगा। जीरो 0.02 into 10 to the power 8 वेव नंबर।
Approximately fine. But if you have this type of thing, then you don't need to do so much of approximation. Okay, 10 to the power 8 meter inverse. What you have to do? 58 1. So 0.000. Then ones are 58, and then you will get how much? 42, right? Yes or no? Then again, what you can add a 0 here. Right? then this is around 6, right? So 7 6 is 42, so you can go with 7. Okay, so calculate whatever. I think 0.17 you can write. You don't even need to do anything further on. Okay. Hmm. You will get 0.017 to 10 to the power 8, which will give you 1.7 into 10 to the power 6 meter inverse, right? And now I can write this as C is equal to lambda into nu. Nu will be equal to C upon lambda. So you know 1 upon lambda, it is equal to 1.7 into 10 to the power 6 into 3 into 10 to the power, how much tell me? What is the speed of light? 3 into 10 to the power 8, no? So this will be in meters. This will be in meter per second. And then we can go at something like this. It is will be 21, 23, and 5.1. 5.1 into 10 to the power r plus 14 meter, and meter will be meter inverse. This will be meter, so we can speak with it and we will get second inverse as the answer. Okay, so this was a barely question of 5 minutes. Barely. Okay, write this down. आयशा ने भेजा आंसर या नहीं भेजा? आयशा ने अभी तक नहीं भेजा आंसर. क्या हो गया आयशा? हाँ, इतना डिफिकल्ट था क्या?
सर गलत आ रहा है.
गलत आ रहा है मेरा या आपका?
मेरा.
आपका गलत आ रहा है. क्या गलत आ रहा है बताइए, कहाँ पे? दिस इज वेव नंबर, राइट? 1 अपॉन लैम्डा. ये गलत आ रहा है आपका? देखिए देखिए कहाँ गलत आ रहा है.
मैंने फ्रीक्वेंसी इज इक्वल टू 1 बाय लैम्डा इनटू सी.
सही किया आपने, क्या दिक्कत है? हमने भी वही किया है. आपने क्या किया? 1 अपॉन लैम्डा इंटू सी ना. सेम ही तो है, ये तो है. देखिए दिस इज 1 अपॉन लैम्डा, दैट इज द वेव नंबर. ये आपका सी है. ये ना 1 अपॉन लैम्डा. आई हैव आल्सो डन द सेम थिंग.
पता नहीं गलत क्या.
देखिए ये आपका सही आ रहा है. दिस नंबर 1 अपॉन 5 58 इज इक्वल टू 0.17. यही गलत आ रहा है आपका. यही देखिए ना, यही पे मिस्टेक है. यानी आपकी एक्सपोनेंट्स एक्सपोनेंट्स सही आ रहे हैं या वो भी गलत आ रहा है? हाँ, सेंड मी व्हाटएवर यू हैव डन ना आयशा. देखिए बताते हैं. सेंड मी व्हाटएवर यू हैव डन. इतना ही किया है क्या आपने? हाँ आयशा. ओके ओके, सॉरी. अरे -8 है ना आयशा, 18 कहाँ से लिख लिया आपने? हाँ आयशा, 18 कैसे लिख लिया आपने?
कहाँ?
Look at the first photo that you have sent. You have written frequency is equal to 1/5800 into 10 to the power -18, वो भी लिख दिया आपने, -18, it will be -8 ना? दिखा या नहीं दिखा आयशा? It will be -10.
नहीं,
अरे look at the first send me the full photo, ये वाला, ये मत भेजिए आप, send the whole page.
सर वो डिनोमिनेटर में 5800 इंटू 10 रेज टू -10 होना चाहिए ना वहाँ?
डिनोमिनेटर में, हाँ वहाँ एग्जैक्टली
अच्छा
देयर,
अच्छा, ओके
ठीक है, ओके।
ओके।
उसके बाद अगर आप देखिएगा ना, व्हाट यू हैव डन, यू हैव इंक्रीज्ड, इट शुड बी 10, यू हैव डन इट 18, और आपके आंसर जो आ रहा है दैट इज 5 into 10 to the power 6। इसमें अगर आप क्या किए हैं, यहाँ पे आपने मतलब 8 घटा दिया है, राइट, यू हैव एडेड 8, you have added 8 here, you add 8 here also, it will be what the correct answer, 5 into 10 to the power 60, sorry 14, तो यहाँ पे आ रहा है, okay, that's the only mistake you have done in
ओके
conversion,
सर, समझ में आ गया।
आ गया, okay। 1.6 आपने लिखा, 1.7 आ रहा है, so approximately it is fine। आधे घंटा लगा दिया आप लोगों ने, बताइए, इतना छोटा सा सवाल है। Done, yes or no, please tell me।
डन।
Then you will write electromagnetic spectrum। Other first what you will write, electromagnetic radiation, then you will write about electromagnetic spectrum। Electromagnetic radiation, EMR, or we also call this EMW, electromagnetic waves, electromagnetic waves, right? The first point, what are electromagnetic waves? You say, so electromagnetic waves, they consist of what, both electric field and magnetic field। You have heard of this word earlier, yeah, for this is the first time you're hearing this word, electromagnetic radiation? Tell me,
Yeah,
first time you have heard it, right? They have both electric field as well as the magnetic field, please write. These consist of electric and magnetic field that oscillate in the direction perpendicular to each other and both are perpendicular to the direction of propagation, and both are perpendicular to the direction of propagation। Next point will be all electromagnetic wave travel in same speed. That is, what is the speed? 3 into 10 to the power 8 meter per second in vacuum. You will write here, okay? And you're writing the properties of in vacuum. Vacuum is double C or only, I think only W is there in vacuum. Vacuum, yeah.
Double C single U.
नहीं, W तो है. There is W in vacuum. I am sure of that. I am not sure of double C. But I think only one C is there and W is there. Can someone check it?
Yes, correct.
Correct. Okay. And also these do not need any medium of propagation. That means they can also travel in space. Done everyone? Yes or no? Please tell me.
सर आप पहला पॉइंट एक्सप्लेन कर सकते हैं?
Do you know about electric field and magnetic field?
इलेक्ट्रिक फील्ड, मैग्नेटिक फील्ड पता है.
Okay. So you know what is magnetic field? Tell me what is magnetic field.
So the area in which the force of magnet can be felt.
Acha. Now in those terms, think about like electricity it is generated with through what?
Movement of charges.
Correct. Now think about charge and then think about the same thing. Like you have for north and south pole, no? The magnet, if it has north and south pole, what will happen? There will be
Positive.
Sorry, there will be some field like this, right?
Negative.
Same thing, positive and negative. So those fields are known as electric field. Okay.
Okay.
Understand this? Okay. Now they will have phases. Okay. Electric field and magnetic field, they have phases like this. So this is in the positive phase, this is in the negative phase, right? And you can associate that if it is in positive phase and if there is anything other which is in also positive phase. And if you will add both of these things, then what will happen? As wave, their amplitude will increase. That's it. You understand this now? How they have these, they contain electric and magnetic field that oscillate in the direction. That means we are talking about the waves now. Okay, we're talking about the waves. Positive phase and negative phase will be there. You understand now what is electric and magnetic field, right? Yes or no?
Okay.
Okay, and then they oscillate in the direction perpendicular to each other. That means the electric field is in x direction, magnetic will be in y or z direction. So if this is in x, this will be in y, and the direction of propagation will be the z direction. X, y, and z. You will see in 12th standard now, you will have this electricity and magnetism in physics. Then only you will understand it in a better way. I'm sure you will know things that it is having electric field and magnetic field. But the understanding it will come only in 12th standard when you do problems associated with electric field and magnetic field. Then you will understand it better. Okay. Is this done? Yes or no?
Yes.
Now write electromagnetic spectrum. electromagnetic spectrum. So in electromagnetic spectrum, it is just the arrangement of different types of electromagnetic radiations in the order of increasing wavelengths or decreasing wavelength, as in whatever you want to arrange it in. Okay. So the electromagnetic radiation that you have to start with is cosmic rays. Acha, one thing about cosmic rays is that cosmic rays is kind of not an electromagnetic wave, but please still write it. Okay. Cosmic rays. Then after that you have X-rays. No, wait a second. Cosmic के बाद एक second. Cosmic gamma XUV visible IMR. Cosmic gamma rays. The sign of gamma. I hope you guys know this. I don't know. This is gamma. Gamma rays. X-rays. Cosmic gamma. XUV rays. Then you have visible region. Cosmic gamma XUV visible infrareds IMR. Infrared. Cosmic gamma XUV visible IMR. Microwave. And then you have radio wave. Okay, so how I remember this one is as it is. Cosmic gamma XUV visible IMR. So if you repeat this line a few times, then also you will remember cosmic gamma XUV visible IMR. Cosmic gamma XUV visible IMR. Okay. Cosmic gamma XUV visible IMR. As we go down, the wavelength increases. And the frequency decreases. And we will also see this later. Also, right, energy also decreases. Okay, we'll see what is the relationship. Energy also decreases. So visible region will be in VIPG or okay. Okay, VIPG or what will be VIPG or? That means violet will have, if you go like this, decreasing wavelength. Always remember violet is near UV and UV is more powerful than infra. And red is near to infra. Infrared and UV. Ultraviolet, infrared. Ultraviolet. Ultra means high. That means you will have high frequency. It will be above. And then infra means less. It will be lower. Done with this? Yes or no? Please tell me. Done, guys? Yes or no?
Yes, sir.
Done, no? Okay. Okay. Right, next. Planck's quantum theory of light. Okay. Planck's quantum theory of light. Now, in this first we will understand, and then we will write about Planck's quantum theory of light. If you observe a, let us say, if you observe a iron bar, let us take. So I'll take this. Take an iron bar, and if we start to heat it, then if you start heat and the temperature will increase, and then it will become red hot. Okay, it will become red hot, and if you still keep on increasing the temperature, slowly it will get towards somewhere around whitish bluish yellowish type of thing. So let me tell you, after that it will become kind of white, and if you keep on heating it, at the end it will get a bluish light. Okay, so it will get a bluish type of color. So first of all, it was somewhere around orange, red, yellow, right? So somewhere around orange or red or yellow type of thing. Slowly it went and became kind of white, and after that it became blue. If you, and what we were doing in this process, we were heating it. So obviously the blue iron, once it is heated, when it acquires the blue color, it has the most energy, right? It has the highest energy. And when we have heated and it is in orange state, and it is having lower energy. Right? And similarly, it is also radiating some energy, right? It is radiating, because if I stop heating it, what will happen? Slowly it will cool down, and what will happen? It will radiate energy. And even if you have your hand near this iron, you can feel that heat there. You can feel that heat there. Okay. And how is this heat traveling? If we are seeing something, okay, if we are seeing something, that means it is emitting light. Yes or no? It is not only having a color. Even if we turn off all the lights, okay, fine. if you turn off all the lights, can you see anything? Tell me, can you see anything if we turn off all the light, even though if they have some color? Can we see it? No, no. But if you have a red hot iron or a blue hot iron, and all the lights are turned off, still you can see that blue and red colored iron, right? So this is red hot iron. You can still see that even if it is a very dark room. That means it is emitting light. Not only it has a color, it is emitting those radiation. It is emitting those kind of waves, red waves, and then yellow, and then blue. That means as we start heating and as the energy increases, what happens? We shift from orange, red, yellow, white towards blue. That means what is happening? We are going from red, yellow, orange towards blue, indigo, and violet. Here the lambda is decreasing and frequency is increasing. So if we are increasing the energy, it is leading to a decrease in lambda and an increase in the frequency of light. And from here, Planck said that I can say E is what directly proportional to the frequency of light. Energy that is associated with a wave, it is directly proportional to the frequency of that wave from this experiment, from this observation of the radiation that is emitted by a hot body, the radiation that is emitted by a hot body. Okay. So with this, what we will write? You understood this, yes or no? This relation, how it came into being?
Yes.
Okay. Right, next. The energy associated with each radiation is called radiant energy. Okay. And also he said that, for example, let us imagine you have a pipe in which you have water, and then what is happening? There is you're watering some kind of wall, let us say, some kind of wall or some kind of flower or anything you can imagine. Now, if you look at this water, you will say that it is continuous wave of water that is coming, right? Continuous wave of water. But you all know that all of these water that you have here, it is made up of H2O molecule. H2O molecule. Now, if you have to observe very closely, then you can see that in very slow motion, you can see that this is not a continuous thing, rather this is a discontinuous thing. One H2O molecule is striking this, then after a very small amount of time, another H2O molecule, another H2O molecule. So even though it looks as a continuous thing, but deep down it is what? It is not discontinuous. It is what? It is not continuous, it is discontinuous. Yes or no? Tell me. Even if you have something looks continuous, it is not continuous, it is discontinuous. So the same thing he also said, the energy is emitted. The energy is emitted. Now, once it is getting emitted, someone will absorb it or absorbed discontinuously. In the form of small packets of, in this form of small packets of energy, which is called quantum, which is called quantum. And the third point that he said was the energy of radiation is directly proportional to the frequency of wavelength. Done. Yes. Okay. Now let's look at the mathematical aspect here. He said that energy is directly proportional to frequency. Okay. And then further he said that if we put up a proportionality constant, we can write it as h nu. What is h here? H is the Planck's constant. You can also write energy will be equal to h c upon lambda, right? Because frequency is equal to c upon lambda, E is equal to hc upon lambda, E is equal to hc upon lambda. So what is h here? Everything will write. Nu is frequency, E is energy, of one photon or one quantum, okay, of one photon. Now, what is c? That is the speed of light, or speed of any EMW, any electromagnetic wave, and h is the Planck's constant. H is the Planck's constant. Its value is equal to, please write, 6.626 into 10 to the power. अच्छा, इसमें please you will remember this, okay? You will not forget this about the Planck's constant. Here when we write the Planck's constant now, this value of Planck's constant is minus 34, 6.626 minus 34, but all the units are not having any inverse value, joule second. Okay, it is not joule per second, it is joule second. Done, guys? Now, right? If n number of photons are absorbed or emitted, then E will be equal to what? E will be equal to the number of photons into hc upon lambda. Or you can also write E is equal to n into h into nu, that is frequency. Okay, because this formula is for one photon. If we have n number of photons, then it will be just multiplied by n, just multiplied by n. Okay, all right, another. Okay, use this short trick. If energy is given in electron volts, okay, energy is in electron volts and lambda is in nanometer, then energy of one photon will be equal to 1240 upon whatever the value of lambda is. Okay, whatever the value of lambda is, you will get this in electron volts. Write this down. So 1 electron volt is nothing but it is just the potential that is required to move one electron. 1.6 into 10 to the power minus 19 joules over a potential difference of 1 joule. So you have that much charge in electron and that many joule of energy is required. Done, guys? Yes or no? Please tell me. Done. Done, yes or no? Yes, Aisha Iram Fahad.
Yes.
Okay. Write a question. Calculate the energy of of 1 mole of photon having wavelength 31 nanometer. Okay, so what they have asked, we have got the wavelength that is 31 nanometer. Okay, and we have got 1 mole of photon. So which formula will we use? E is equal to hc upon lambda, or we will use E is equal to nhc upon lambda? Tell me, guys. Which one we will use?
Second
1 or 2?
Second, yeah.
Iram? Okay. Iram, Fahad, what do you think? First one or second one? Which formula will be used? Tell me.
Second.
Second, right? Iram?
Yeah,
Second? Second, huh? Take it. What will be the value of n here? What will be the value of n?
1.
1. एक मोल में कितना होता है? हाँ, ये तो नहीं पता होगा आप लोग को, है ना? What is 1 mole? Do you know this? आयशा, इरम, 9th क्लास से याद है या फिर भूल गए? हाँ, डोंट नो. ओके, तो सी फहद, आपको तो पता है ना 1 मोल. 1 mole is equal to 6.022 into 10 to the power minus, नहीं, plus 10 to the power how much, Fahad? 23. Okay, so this is 1 mole. So put the value of n is equal to this much. You have this many photons. Okay, put the value of Planck's constant, put the value of light, and then put the value of lambda. You will get the energy. So look here. E is equal to 6.022 into 10 to the power 23 into H is 6.626 into 10 to the power minus 34 joule second into light is 3 into 10 to the power 8 meter per second divided by lambda. What is lambda? 31 nanometer, which is equal to 31 into 10 to the power minus 9 meters. So see, what is the first thing that we do whenever we are simplifying? What do we simplify first? Tell me.
Unit.
Units. Okay, so first we'll simplify the units. So you will get the unit as this. Meters and meter will cancel each other. And also what you can see is this second from here and this second inverse from here, they will cancel each other, right? So you are getting all the energy in terms of joules, and that is fine. That is correct. So what we'll do, we'll write this as it is. Okay, write this as it is 6.022 into, but what we will see, we will arrange them in numbers or integers and the powers of 10. So 6.022, and then what we'll write 6.626 into 3, and we will divide this by 31. Okay, we'll divide this by 31 into, what do we have? 10 to the power 23 into 10 to the power minus 34 into 10 to the power minus 9, 10 to the power 8 divided by 10 to the power minus 9. Okay, now what we need to do, we need to simplify just this. Now how will you simplify this? We'll simplify this like this. This will be 10 to the power 23 plus 8 plus 9 minus 34. ये calculate कीजिए कितना आ रहा है? You understand this now? Minus. Wait a second. 6.022 into 6.626 into 3 upon 31 into half. बताइए कितना आ रहा है? 23 plus 8 plus 6 plus 6.
Yes.
Okay. Waiting for others by the way. Aisha Iram, calculate 23 plus 8 plus 9 minus 34.
6.
Okay. Iram, आपका आया? Okay, all this will be in terms of joules. Okay. Now see what I'm going to do. Please bear with me. I will just cancel this, okay? 3 tens are, and I will write this as by 10, so this will be into 10 to the power 5 joules. Now you just need to calculate 6.022 into 6.626. Multiply this and tell me the answer. Have plenty of space, okay? Have plenty of space in your notebooks.
सर
हाँ बताइए.
ये 6.6 to 6.7 कर सकते हैं.
6 पॉइंट क्या कर सकते हैं?
6.7.
अरे कैसे राउंड ऑफ, ऐसे राउंड ऑफ किया जाता है आयशा? इतना नहीं करते ना, इतना नहीं करते. आप इसको ये कर लीजिए, आप इसको 6 ले सकते हैं, ठीक है? दैट विल बी फाइन. You can take this as 6. You can do this as approximately, you can do this in the rough page. What you will do, 6.626 into 6, है ना? 0.022 will not make much difference. Fine, इतना तो कर ही सकते हैं. राइट इन चैट, राइट इन चैट. आपकी आवाज सही से नहीं आ रही. Just don't write the exponents and powers, okay? Just give me the value. Okay, Iram. So, Iram, what did you multiply? 6.626 into 6 or 6.022
No,
into
no,
6?
sir. 6.022 into 6.626.
Okay, fine. What about Fahad and Aisha? What is the answer that you guys are getting?
सर व्हाट्सएप में सेंड करूं?
हाँ, सेंड कर दीजिए व्हाट्सएप में. No problem with that. फहद आपने भेजा है क्या आंसर? नहीं, हाँ हाँ फाइन, इट्स करेक्ट. Okay. Okay. So these guys will be getting 39.756 10 to the power 5 joules. So you can write this as 3975.6 into 2 decimal places, 10 to the power 3 joules, and 3975.6 10 to the power 3 means 1000, thousands means kilojoule. Okay, so this will be your answer. All of you done, yes or no? Please tell me. Yes. Okay. Wait. Oh, yes, sir.
Sir, yes, boy.
Okay. Yes, sir. Okay. Right, next. A 25-watt bulb emits radiation having wavelength 62 nanometers. Okay. Calculate number of photons. Calculate number of photons emitted by the bulb in 1 second. So a bit of 10th standard physics is needed here. What is the unit of? Tell me, what is the unit of what? किस चीज की unit है watt?
Power.
Power, right? Very good. So what is power? Power is sorry. Power is yes. What did you say?
Force upon distance, length.
नहीं.
या फिर work upon time.
Work upon time. And work, you can say it is what? It is energy upon time. Right? It has same units. Energy upon time. Energy is what? Energy will be equal to power into time. So power is 25 watt into 25 watt into 1 second, right? So this will be equal to 25 joules. So this is the energy that is present. Okay, and now what we have the energy, and again they're asking the number of photons. Then we will use which formula? E is equal to nhc upon lambda, right? We have here what? We have here the energy that is 25 joules, which will be equal to some number into the Planck's constant that you know the value of, into c that you know the value of, upon lambda that you have been given, right? What is the lambda given here? 62 nanometers. So you write lambda is equal to 62 into 10 to the power minus 9 meters, right? So you have all the values now. What you need to calculate? You need to calculate a number which will be equal to 25 into lambda upon h into c. So calculate this. You know the value of lambda, which is equal to 62 into 10 to the power minus 9 meters. Please calculate all of these values. You have to calculate the number. Again, write everything in units. Have a large space, okay? Here 25, the unit will be joules, okay? Okay, I have got an answer. Okay, fine, we will see. Iram, send the answer on WhatsApp. I want to see. Also, Fahad can't. Okay. Iram, send your answer. You have taken care, Iram, while calculating?
Yes, I'll send you.
Yes. Okay. Array, Iram, what is the value of Planck's constant? Iram, what is the value of Planck's constant?
Oh, sorry. Samjha.
Okay. And let us see. Aisha. Joule, meter. Okay. You have, okay. Oh, 3 into 8. Okay, fine. 10 to the power minus 9, 10 to the power minus 34, and 8. Okay. Okay. And from here you have got, okay, fine. Now that is something. But I think your answer is not right somewhere.
Yes sir, वो पता है गलती हो गई बीच में, चेक कर लेते हैं।
है ना? I think exponents are fine, I guess, right? है ना? Exponents, like, it is not very far away if I talk about exponents, but the 12.7 लिखा आपने, I think that is not right.
सर मेरा करेक्ट है?
आपका करेक्ट तो है. Okay, so rather than doing 8 3 से 24 आपने 25 को कर दिया. That's fine. मतलब उतना that may be okay. Okay, so I think all of you must be getting like this something. Let me write 25 joules into 62 into 10 to the power minus 10 minus 9 nanometers. No, meters. Planck's constant 6.626 into 10 to the power minus 34 joule seconds into 3 into 10 to the power 8 meters per second. We can cancel this, 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 and this, this, and this, and we are getting number. So obviously number will not have any unit, it will be unitless. Furthermore, we'll have 25 into 62 divided by 6.626 into 3 into 10 to the power minus 9. This is 34. This minus 34 will go above, it will become plus 34. 8 will go above, it will become minus 8, right? So this whole thing, it will be minus 8 and minus 9, minus 17, minus 17, minus 34, it will be giving you plus 34. Minus 17 plus 34 will be giving you 10 to the power 17. Now, let's look at this. So actually what Aisha did was, she was like 3 8s are 24, that's it. I will be fine, okay, fine, that may be done, it can be done, an approximation kar sakte hain, but only once. And then she did something, 62 8s are 496 divided by 6.626 into 10 to the power 70 into 10 to the power 17. Okay, now here what I will say, here you can do something like 496, you can take at least 3 zeros or something if you want, or you can approximate this to as 6.6 also. Okay, so rather what I will do, I would not do 6.626, I will do 6.6, and now it gets a bit easy. Okay, and from here what you are going to do, 4960 divided by 66 into 10 to the power 70. Both of these are same things. Then you will divide 66, 4960. Now 6 8s are 48, right? 6 8s are 48, but probably it is 49, just 66, more than 65. I think it is better to go with 66 into 7. So 7 6 are 42, 7 6 are 42, 46. So can we go one more? 462 is right, right? 7 6 are 42, 7 6 are 42, 42 plus 6 46. We can't go further. So 7s are 462. I will get here 4, 9 and 6. I will be getting here 3, and here I will be getting a 0. Now 6 5s are, I don't think 6 5s I can go because it is 66. It will be more near to 7. So I will do 66 into 4. 6 4s are 24, 6 4s are 24, and 26. So I've got 2 6 4. Now it will be how much? This will be 6, and then this one will be 13 minus 6 will be equal to 7, no? 13 minus 6. I think we can go one more. I think we can go 66 into 5 also. Let me see. 30. Yeah. Zero and 1. Fair. So here 75, right? So you will be getting 75 into 10 to the power 17. Okay. I don't know how Aisha, whenever you have decimals ना, आप उसको whole number में change करके divide किया कीजिए. Okay, this is for everyone by the way. Aisha, Iram and Fahad. Whenever you have decimals while dividing, you convert them into whole number. You understand this step, right? Yes or no?
Yes.
Huh? No, what about others?
Yes,
Aisha,
yes.
yes, no? Okay. Fahad, you got your mistake? Yes or no? Tell me.
Yes, sir. Maybe.
Okay. Fine. Okay. So on Thursday, you will have a subjective test. 30 minutes, 10 marks, and the topic will be waves, whatever we have learned in the last class, and electromagnetic waves, Planck's theory. Okay, so it will be a mix of some theory and numericals also. Okay, I will not be giving purely numerical or purely theoretical questions. There will be theory also some part, and there will be numericals also. Okay. So please practice now. Okay, start practicing. You have first of all NCERT that you will practice from. You just practice from NCERT and that will be okay. Okay. So whenever if you see any question in which there is lambda or there is frequency or there is energy, so all of these questions you can practice from NCERT. At least what you can do, you can redo the class numericals. Okay, and after that you start doing NCERT. Is that clear? Yes or no? Please tell me. What happened? Aisha, Iram, Fahad. Acha, हाँ, one more thing. Last class में जिस तरह